Hi students, okay, today we are learning the topic is vector differentiation. So vector differentiation, already we learning the topic is differentiation in the general function. So but here differentiation of vectors. So here vector point function and scalar point function. What is a vector point function? The vector is a function is involving the unit vectors, that is I, j, k. So that is called the vector point function, and that function is defined at every point in the given region. So similarly scalar point function. Scalar point function means, so without ijk only the function is real valued. Only that is called, that function is also defined at every function in the given region, that is called scalar point function. Okay now. So first of all, we in this topic, the first one, gradient and directional derivative. So what is the gradient and what is the directional derivative of the given scalar or vectors? Okay, first definition is gradient of a scalar field. So gradient of a scalar field, what is the definition is here? So the direction of the greatest rate of change of a scalar is called gradient of a scalar. So gradient means here vectors, and gradient of a scalar, that is called a vector form. So vector, what is a vector is the greatest rate of change. So vector differentiation means rate of change here. So in the vectors form, gradient of a scalar field means the direction of the greatest rate of change of a scalar is called gradient of a scalar, and a gradient of a scalar is always vector. So or another definition is, so a vector differential operator is del. So this is the operator del is called del operator, and it is denoted defined by del is equal to I dou by dou x plus dou by dou y plus k dou by dou z, and a vector differential operator, that is dou by dou x, and because this is a function, scalar or vector is function having more than one variable, that is called partial derivative. So I into dou by dou x plus j into dou by dou y plus k into dou by dou z. This is also can be the simple form is summation I dou by dou x. So summation expand next to j k. Okay na? So this is called vector differential operator. So therefore the gradient of a scalar field f of x comma y comma z, here f of x comma y comma z is a scalar and is denoted by del f. Del f is gradient of a scalar field, or the another form is grade f. Grade f is also gradient of a scalar field, is defined as, and a del is operating on f, that is equal to is del f or grade f is equal to I dou f by dou x plus j dou f by dou y plus k dou f by dou z. So also simple form is summation I dou f by dou x, so which is always vector. So gradient of a scalar field is always a vector. So next one is unit normal vector. Okay na, see the next definition, unit normal vector. Let f of x comma y comma z is equal to c, where c is a constant, be a surface, that is any surface, and then the normal vector of f is defined as del f, and the del f means gradient of a scalar field. The gradient of the given surface is called normal vector, and it is normal vector is also defined as n cap is equal to del f by mod del f. N cap, that is a unit normal vector. How to define? Unit means its vector magnitude of its vector is always 1, and the mod of vector is always 1. So this is mod of del f by mod del f is always 1. So and how to finding the unit normal vector? Del f by mod del f, that is called unit normal vector to the given surface f of x comma y comma z is equal to c. Okay na? This is the two definitions. So remaining definitions, unit tangent vector. Let r bar is equal to I x of t plus j y of t plus k z of t be a position vector of a point p of x comma y comma z on any curve. Then tangent vector is dr bar by dt and unit tangent vector is dr bar by dt by mod dr by dt. And this is a position vector r and ij plus yj jy plus kz here. So now differentiating of r with respect to t, dr by dt. So dr by dt is a tangent vector and its unit normal means that is called dr by dt by mod dr by dt. So that is called tangent and unit tangent vector. So see the note here. So assumption r bar is equal to xi plus yj plus zk. So dr and differentiation I dx plus j dy plus k dz. If phi is any scalar point function, then del phi is the total differentiation only. Phi is a 3 variable function. Already we discussed in the previous class. Differentiation of phi is the total differentiation. D phi is equal to dou pi by dou x into dx plus dou pi by dou y into dy plus dou pi by dou z into dz. So which is also can be right I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. Next ఇక్కడ I dx j plus j dy plus k dz. That is the product is dot product. So that is a del pi. This is a gradient of phi and d bar. This is one of the notation. Okay na? So next properties of gradient. So let f and g are scalar point functions. Then the first property del of f plus r minus g ante adding and substituting of two scalars is equal to separate del f plus r minus del g. And del f is equal to 0 bar ante del f is a 0 vector when f is must be constant. Del of f into g and the product of the two scalars that is equal to vector differentiation is f into del g plus g into del f. Next fourth one del of the with constant coefficient of a scalar c is outside of the vector form c into del f. And del of f by g the division of two scalars that is equal to g into del f minus f into del g by g square where g is not equal to 0. This is one of the properties. So see the next definitions. So directional derivative. So let f of x comma y comma z be a differentiable scalar function. Then the directional derivative of f in the direction of a vector b bar at any point p of x naught comma y naught comma z naught is defined as del f dot b cap, where b cap is a unit vector of b bar. And to finding the given any surface, there is any function, to finding the directional derivative of the given surface in the direction of any other vector, that is a b bar at the point p is defined as del f dot b cap. Del f is a normal vector dot b cap is a given direction vector of unit vector. So it is denoted by this one, directional derivative of given surface of the function del f dot b cap, where b cap is equal to b bar by mod b bar. Okay, next definition, maximum directional derivative. The maximum directional derivative of the scalar function f of x comma y comma z at the point p of x naught comma y naught z naught is defined as mod of del f. That is the magnitude of gradient of a scalar function f, that is mod f, mod del f, sorry. Mod del f is called the maximum directional derivative of the given scalar function f at the point p, and also this is called in the geometrically greatest rate of change at p. So next definition, angle between two surfaces. Let f of x comma y comma z is equal to c1 and g of x comma y comma z is equal to c2 be two surfaces and theta be an angle between them, so that angle theta is equal to the angle between their normals and is defined as cos theta is equal to del f dot del g by mod del f into mod del g, where del f is normal to the surface f of x comma y comma z is equal to c1 and del g is normal to the surface g of x comma y comma z is equal to c2. And to finding the angle between two surfaces and both surfaces are intersecting at the some point, there is no directly finding the angle between them. First of all, draw the normal and first finding the normal vectors to the given surface, then angle between their normals is equal to the angle between two surfaces. This is the formula for finding the angle between two surfaces. Okay na? So next one, Laplacian operator. So Laplacian operator is del square. Del square means del dot del and a two time differentiation. Vector differentiation two times. Del dot del is equal to del square is called Laplacian operator. For example, here phi is a scalar function. Del square phi can be write dou square pi by dou x square plus dou square pi by dou y square plus dou square pi by dou z square is also scalar. Okay, this is the basic definitions in vector differentiation. Yeah, thank you. For more videos, please do subscribe my channel, like and share it. Thank you.